Hello ladies and gentlemen, welcome back to Chemistry with Mr. Dang here. You should have this paper in front of you. It's worksheet acid 8.2 acid bases here. We're going to go through a series of worksheets, so make sure you follow through these videos, take notes in addition to it, on the side, on the margins, on a separate piece of paper, whatever it is you need to do to have the information that you need for this unit. Okay. By now you should have done the reading online, the reading that was posted on Canvas about acid and bases. You have to have done that in order for you to do this page, because it provides a lot of information that you need here. So using the reading, go ahead and complete this chart, this first two chart here, acid and base. Get all the properties of those two on there. And so to start this part, I want to go over what we call strong acids and strong bases first. And as far as strong acids and strong bases, there are only a short list of strong acids and strong bases, and the first one I'm going to go over is the 7 strong acids. Here are the 7 strong acids: hydrochloric acid, hydrobromic acid, hydroiodic acid, nitric acid, chloric acid, perchloric acid, and sulfuric acid. So it says here list 3 strong acids. List 3 strong acids and explain why these are considered strong acids. And I'm going to use a different sheet of paper to explain that. Okay, a strong acid, what it's going to do, it's going to dissociate or ionize completely in water. So what's going to happen to this HCl is it's going to split up to H plus and Cl minus. It's going to split up completely. So if you add that to water, it splits up, and what's going to happen is this hydrogen is going to combine with water to find H3O, and sometimes you see this as hydronium. And a hydronium is equivalent to a hydrogen in water, basically. So this is a hydrogen, because in water it's going to add to H2O. It's going to form that hydronium ion. So you see these are interchangeable. Sometimes you see the concentration of hydrogen and the concentration of hydronium. They're the same thing. Okay? And so with strong acids, they split up completely, ionize completely, dissociate completely. Those are some words that you might see interchangeably there. So the 7 strong acids, you have to memorize these: HCl, HI, HBr, HNO3, H2SO4, H2SO4, HClO3, HClO4. Okay. So basically most of the chlorate, the chloric, the hydrochloric, and perchloric acid there, those are strong, and then the HIBRNO3. These are the strong ones. All the other ones are weak acids. Things like HCN, H3PO4, CH3COO, acetic acid, and these are weak. Okay, these are strong. So memorize the strong list, and everything else will be weak. All right, memorize that. And then on the bases, and by now you should know what bases are. If you don't, go back to the reading assignment. Okay, strong bases, there's 8 of them: LiOH, NaOH. I'm going to split it over here, move this over the screen here so you can see a little better. Okay. LiOH, NaOH, KOH, RBOH, rubidium hydroxide, cesium hydroxide, CaOH2, SROH2, and BaOH2. And notice where these are on the periodic table. Basically, when I have a periodic table like this, most of the strong bases are like lithium, sodium, potassium, rubidium, cesium. So basically every single metal on the first column With the hydroxide, that's a strong base. And you add a couple more in the second column, the second group: calcium, strontium, and barium. So these are the magic 8 right here. Okay. So there's not much happening with francium, so then really that's not a strong base there. But those are the 8. You have to memorize these as well, so you know that these are the strong ones. Okay. Everything else will be weak. Like magnesium hydroxide will be weak. Calcium hydroxide will be weak. Iron hydroxide will be weak. Aluminum hydroxide will be weak. So everything else are weak bases. And so the reason they're weak, so those are the strong. They split up completely. And the weak acid and base, they only partially ionize. They only partially ionize. What does that mean? That means whenever you have a compound like MgOH2, not all of it, there's still going to be some MgOH2 plus magnesium ions plus OH ions. When it's in water, when it's mixed in water, not all of it will split up in water. Okay, so not all of it will split up, and that's what it means by partially ionized. They don't ionize completely. We'll go more into this as far as what does that mean. Okay, and so for our purpose now, that should answer number 2 and number 5. Complete that, and then use the properties you've learned to complete number 6. Okay, so pause it and you finish number 6 before you move on to number 7. And number 7 here, say what happens when these things dissociate in water to form acids. Alright, so these, some of here are strong acids, some are weak acids. Be able to recognize those. Like this one's a strong one, H2SO4, this one's strong, this one's strong, this one's weak, this one's weak. And so you know, write an equation for dissociation. What's going to happen with H2SO4 is it's going to split up completely into 2 hydrogen with a positive charge, and plus SO4 with a negative 2 charge. It's going to split up completely. Okay, and with a weak acid like this, you'll have some of that still. You still have some of these, plus hydrogen. Some hydrogens will get split up, plus the C2H3O2. Alright, which is the acetic part of that. So you get, when you recognize it's a weak acid, it doesn't split up completely. So there's still some of that. Of course, it's not going to look balanced because these are just counting the number of atoms, and there's so many of them. Okay, we're not trying to balance equations here. We're just showing how they split up in water, and disregarding how many of them there are. Alright, like HNO3 will split up completely into 2 ions. This strong acid, this one, HCl, split up completely. H2S here, you can have, it's weak, so you can still have some H2S, some H's, and some S's. Okay, so complete this before you move on to number 8. Okay, and on number 8 is very similar to the strong acids and strong bases. Write an equation for the dissociation of bases in water. Very similar. This is strong, this is strong, this is strong, this is weak, this is strong. Right? Oh, they have the same thing here. E and A are essentially the same thing. And just, they didn't do that as far as here. They show that they all split up completely. But that's the main thing that's going to happen. But just realize that it is a weak, so then it won't, you still have some MgOH that are still together. Okay, and be familiar with that. So this one, Na, it will split into 2 ions here, Na plus and OH minus. And so go through, do these, try these, and if you have any questions, or you don't understand something, or you want to say something like this:
what do you mean?
And so ask me questions before you move on to the next assignment.